Uh, Hi everyone, welcome back to my channel. Hope you enjoyed the introduction to our rdkit package and the list of sub-libraries and their features and how it can be used for molecular modeling and drug discovery tasks. Now, in today's session, we are going to discuss about rdkit installation by different methods, and followed by we'll have an overview to the rdkit chem module and highlights and how to implement those features in Jupyter Notebook. Right. Okay. So before we start with going with our rdkit chem package and their implementation, so we have to install Anaconda. So to install Anaconda, so you need to go to the anaconda.org, download Anaconda, and download respective package of your interest as per the operating system, if you're Linux version or Windows version. So install the Anaconda. It's a pretty straightforward. You can easily install that. And after installing the Anaconda, you can go to the all programs, open Anaconda prompt, Anaconda terminal, we can say. Now, in the Anaconda terminal, if you want to activate or if you want to create your own environment, there are different options. Either you can actually create a fresh environment, or you can create environment using YML file, which I provided in my GitHub page. And I shared my GitHub link and YML file, path, and everything in my YouTube description. So you can refer to that. Now, for example, let's see, you want to start something fresh. So all you need to do is, by using Anaconda, you need to create the fresh environment, like as you can see in my notebook here, notepad. So conda space create hyphen n my n. So here we can say rdkit or maybe uh, the name of your interest. So here I'm keeping my n and Python version of your interest. Like if you want to install any specific version, please go ahead and try. And I'm not going to create any environment for during the demo. So it is just for explaining purpose only. Now, once you successfully complete this step, all you need to do is conda activate my n. So, or the name of the name that you provided to create an environment. So after that, so if once you activate in the environment, so you can see the environment name here instead of base. And once you are inside of the environment, you can actually see uh, list of packages that is being installed, or what is the version of specific package or Python version, everything that you can play around. Now, once you are inside the package, once you are inside the environment, so all you need to do is conda, conda install -c conda forge rdkit. So it is gonna, this command will install the rdkit in that environment. Now after that, so if you want to, I recommend actually, if you are planning to follow my tutorial, or if you're planning to work on the practice of this tutorial, so all you need to do is you need to install some supporting packages that is required for uh, rdkit if you want to handling the bigger file systems, or if you're handling with especially CSV files, if you're planning to convert into the uh, you know especially if you are planning to you calculate descriptors, or if you're planning to play with the larger file system. So it's always recommend to install pandas and followed by numpy and cbon and matplotlib. So you can try to install like this, a pip install numpy and similarly cbon, right, and install. Then similarly, you can pip install Jupyter as well, right? But here, I'm not going to create an complete new environment here, because I'm already having an environment that's called rdkit.yml. So in order to use that specific YML file, all you need to do is conda env create f the YML file name that I provided. So we have seen how to create an environment from scratch and what are the packages that is required for this demonstration. And the second step will be, instead of going to step by step and installing the packages and make sure they are compatible enough or not, so you can also use the second method. So where you can create an environment from the .yml file that I provided. So once create this one, so all you need to do is, let me jump onto this one. So once this package, everything is done successfully. So you can actually try these commands. Let me close this terminal. So conda env list. So that will actually retrieve all the environment that's been installed in your system. So it will take for a while in my system because I have a lot of packages, a lot of environment that has been installed. So it has to retrieve those one. So here you can see I have a rdkit training has been installed. So now I'm going to activate that rdkit training. So initially it was, you can see base and followed by file path, folder path, and now after activating, I can see rdkit training. So what now, whatever I'm going to do, so if I'm going to install specific package by using pip or by conda, or if I'm uninstalling, so everything that will be inside this environment. Now let's see what are the packages that's been installed along with this rdkit training, right? Okay, let me zoom it off. Okay, so when you install rdkit.yml, so the majorly I'm not going to the all packages, but majorly package of my interest is IPython and Jupyter, and followed by pandas, Python. You can see Python 3.6 that comes with this environment. Now Seaborn, right? So these are the supporting packages that I install that is available in this environment. Okay, now let's jump onto the Jupyter Notebook. Sorry. Let's jump onto this. Let's try to launch Jupyter Notebook from this command line. Okay, so I have a lot of you know Jupyter notebooks that has been created and that's been saved in my Jupyter in my GitHub as well. The link that I provided. So you can use these notebooks for practice purpose or learning purpose or just to refer if you want. So I'm just going to launch one of the Jupyter notebook that I created. Let me check. Okay, this is the one. Okay, so let me move this. I'm not going to use that. Let me create a file from scratch. Okay, so this is a Jupyter notebook. So before we jump onto the rdkit and rdkit demonstration, so I just want to give a brief intro about Jupyter notebook, and uh, that will be helpful for the completely new user. So okay, in the file system, let's go ahead with one by one. The file system, if you want to create a new notebook, so you can actually go to the new notebook and Python 3. And if you want to open a specific Jupyter notebook like a .ipynb file, so you can go to the file open and browse the file and launch it. If you want to download the Jupyter notebook in HTML version or LaTeX version or PDF or Jupyter notebook version, you can actually do this from here. And especially now go to the edit. So here in the edit, you have options very useful. Some of the options are copy and cut and paste the cells. So you can move up and down the specific cells by clicking this one. For example, if you want to move the specific command up before executing or after executing the main program, so you can do that by using here. Now, the next one. So another important thing is toggle line numbers. You can go to the view and toggle line numbers. You can actually see the line numbers here. And now go to the insert. If you want to insert a specific cell before this one or after this one. So for example, you can see insert below. Now, coming to the run. So we'll discuss about run and kernel here again. Okay. Now come back to this cell. So now we have seen the basic functionalities of file, edit, view, and insert and cell. And there is some shortcuts as well. Uh, so you can actually save on checkpoint here, or if you want to insert a specific cell below, you can see that. And similarly, if you want to cut the cell, you can actually try these options and copy and paste the cells and moving the cells up and before and after, you can try that run pause. For example, if you execute any cell and it's taking a longer time, you can actually interrupt the kernel and restart again. So this is the restart a kernel. And this is going to the next step, restart the kernel and read on the whole notebook. Okay, now see, there are, within the cell, you have an option. When you click on the specific cell, you can actually change the, either the cell belongs to for a coding purpose or markdown or heading. Let's select a coding here, right? So currently it's showing code. Let's go to the heading. So now let's add a heading here. So rdkit demo 2. And after creating heading, you can actually run it. So you can see the header here. Now let's add a markdown. So I want to add, so during this session, we are going to learn rdkit.ym package. Now click on run. So you can actually add the commentary, or if you want to note something specifically important, you can actually do that by using markdown, right? Now let's change. Now this is when you select a specific line, you can actually see whether that belongs to coding or that belongs to markdown or heading. Now here, now go to the cell, you can see run cells, right? Run all. For example, imagine you have a code. Let me take this as an example here to explain that. Sorry, there's nothing. Okay, so you can see the in the within this Jupyter notebook. So everything has been executed and saved. So all, if you, for example, if you click on this run all, it is going to restart again and run again everything, right? Now go to the all output clear. Now you can see the output is everything is has been cleared. Now you can see only the codes, right? Now click on run all. So you can see it started executing all the cells from scratch, right? Now restart and clear output. So what it is going to do is, it should do that. Okay, something again. Okay, so when you click on restart and run all, so it actually removed everything, whatever the output that's been saved, and restarted again everything. So that's been, useful features if your code is actually stopped. If you want to rerun a specific code again by changing the inputs, you can actually try to do that by using these two options. Okay, now let's move on to the Jupyter Notebook that we are working on it. Okay, so the first command, let's try to import rdkit just by typing rdkit from rdkit import chem. So here is a Python is case sensitive. So you can see here I actually said import chem. So always it should be capital because it's a very case sensitive. Right. So as we have seen in the introduction session, there are a lot of libraries that is available in rdkit, like main library is chem, and within the chem you have a lot of other libraries to support molecular manipulating functions or file handling systems or geometry optimizations, right? And drawing the reaction. So there are a lot of other sub packages that is been available. If you want to import that libraries, all you need to do is go to the rdkit.chem import draw, right? Now similarly, you can import all these libraries like RTML descriptors, depictor descriptors, and fingerprints, everything by from Alchem as well. Okay, now let's start creating a variable. I'm creating called molecule one. So here, what I'm trying to do is I'm actually trying to uh, create a smiles string and trying to read using rdkit chem library. So for that, I'm actually calling chemistry rdkit chem function. When you click on the tab, you can actually see all the function that is been associated here. So now click on the mole. So here, let's try to launch smiles. Okay. Now provide the smiles here. Okay. And enter. So what we did, we actually provided smiles and to the molecule one. And we are actually using chem library and function is mole from smiles, molecule from smiles. Now let's see what is inside molecule one. So this is what we stored in molecule one. Now let's print what is inside the molecule one. So this is actually rdkit mole object, right? It is saved as a rdkit mole object. We can try to use a drawing function to draw the molecule and also use the print function to see what format it is saved, right? Okay, so let's move on to the next one. So here in this specific session, what we are going to do is we are trying to cover the different examples of rdkit.chem libraries, right? So where we are going to see how rdkit.chem handles and read and write the molecules in different file formats and molecule manipulations, including atom and bond manipulations and substructure searching, molecular descriptors and fingerprints, calculation and molecular property predictions, including log P and solubility, right? Let's start with the first one, the reading and writing the molecules, right? So for that, what I'm trying to do is I'm trying to use heading here, add another hash. Okay, now enter. So during this demo, what we'll do is we'll start reading and writing the molecules in different file format. Just now we saw an example of how to read a smiles by using rdkit .chem function. And similarly, we'll try to see what is the other file format that we generally handle in day-to-day as a being as a comp chem. So like handling a smiles, SD file, mole, and PDBs. right? Okay, let's start with an example. So, so we have seen an example of defining directly mol1 and defining a function, right, to read the molecule. So we can also do in an alternate way. So I'm creating a variable called smiles and defining a smiles here, right? And now, so I'm creating a variable called mol, and I'm actually using the same function, rdkit.chem library, and chem dot mol from smiles, and I'm actually providing a smiles back here, right? And let's see what's the mol. So it's the same step that what we have did above. So whereas here directly we provided molecule one, and we try to read the molecule smiles from uh, mole from smiles actually. So, but here what we try to do is we actually provided a variable called smiles, and we actually, you know, mention the smiles thing here, and we actually call the smiles variable here, and we try to do the alternate way as well. Now, let's save this same molecule the into the st file function, right? So now what we did, read a molecule in smiles format. Okay, now let's write the molecule to an stf file, right? So for that, what we are trying to do is with the file open function, actually creating st file name, right? And what we're trying to do is write as a f dot write, and we are calling a chemistry function here, mol2, mol block, and what we are trying to save here is mol. Well, okay, sorry, that. Okay, sorry for it. Now you can actually see whether the file is saved in the folder or not. So this is a file that we just created now, right? Okay. So what we try to do is we actually try to uh, read the molecule in smiles format and try to save it in st file format, right? It's interesting, right? Okay. Now let's use the mol block function to see and convert into the molecule, right? So it is the same thing. So what we are trying to do here, we're trying to print the molecule that is stored in mol. So using mol block function. So you can see the mol block here for the defined molecule. So this is all, atom indices and followed by bonding. And if you have any properties or headings and the associated title that is being, you can see the properties here. But here in this example, there's nothing. Okay. Now let's see a few more functions here. For mole, so now we are dealing with this one. We can see only the hydrogens onto the OH group. Let's add a hydrogens, and by using add hydrogens function, let's create a function called molh and call chemistry dot chem, uh, add hydrogens to the mole and print. So can you see the now, right? And now similarly, let's say no hydrogen. Remove hydrogens, all H. So here in this example, what we are trying to do is whatever the hydrogens that we added, so we are trying to remove that. So mole, no hydrogens. So now let's try the same thing in different way. So when consider the remove hydrogens, it removed all the hydrogens except polar ones. So that's why I'm trying to do is remove all hydrogens and instead of all, no, I'm actually creating all H. Okay, that's something that's I think it should remove, but let me check and come back to you on this. Right? Okay. Now what we did, we actually let's recall like what we did. We actually try to read the molecule just by defining a molecule variable and try to print and see whether the molecule is smiles converted into mole format or not. And the second demo that what we have seen, we actually try to read the smiles in different way in the compared to the above example and converting into mole format. And what are the mole format that we converted and we try to save it in SD file format, right? And the next one that we have seen just the basic manipulations, adding hydrogens and removing them, right? Now let's save the molecule in SMA format, .SMA format. So for that, what I'm trying to do is I'm creating a function called W1 and calling Miles writer, and that's at test.smi. Okay, forget to add. Okay, so W1 write. So what we're trying to write is small. Okay, now W1 close. Right. Okay, now let's type ls and see. So the SML file has been created as well, along with the SD file. Right, that's cool, right? Now let's use the same function, same, but here, test2, like test2.stf. So above, we actually try to use the with file open function, and here we try to use the chem.htwriter function to create an SD file, right? Can you see test2.st file, right? Okay. Now let's try to uh, open the SD file and see what is inside our XML file that we created. So for that, I'm trying to use with open test XML function. So I'm actually calling the smiles inside, right? Okay. Now, so what we try to do here, we actually try to open the test.xml file that we created here, and we actually try to add the heading that's called smiles.append. So let's see what is inside modes now. So and convert what are the file that we created. Let me see, smiles. Okay, so the file that we reading is test.smi, and we are actually giving a variable called smiles. So when you print smiles, you can actually see the heading, smiles name, and this is smiles name. So now what we're trying to do is we're actually converting the smiles into mole format. And for that, I'm actually using, if I have a one smile, you can use the same one, right? So that is for one string. Okay. Imagine let's have in the provided SMA file, you have a large number of strings, right? So in that case, you can actually try to use this function. So we're trying to convert smiles, which is provided, which is like present in this variable, right? Now let's use, okay. So now successfully converted smiles into mole. Now I want to draw the molecule and see what is inside. So I'm actually using rdkit draw function and moles to grid image, moles. Okay, so now what we try to do is we actually reading the .ncmi file here and try to see what is inside, and followed by we try to convert all smiles into mole format, calling the chem.mole from smiles function and for in function. Right. Now imagine if I'm using a larger file that has around 50 smiles or something. So you can actually use this command. If you are handling with only one smile, you can actually try to use this function. Now imagine now currently I'm only handling one molecule. So if I'm trying to handle the 50 molecule and I wanted to see all the molecules to be converted into image format and I want to visualize and play ahead. So you can actually try to use this function, uh, moles per row. How many molecules that you want to see per row is 3. You can actually run it. But currently I have only one smile. So otherwise this function is very useful to see what are the molecule that has been converted into mole. You can actually visualize them and make sure they're converted correctly. Right. Now let's take an example and try to use that this function. See, whether the molecules are converted correctly or not, captured correctly or not. So I'm actually for that, what I'm trying to do is I'm trying to take multiple smiles and creating a variable called smiles2 and adding 4 different smiles here, right? Okay. And let me call this one. After reading this, I'm actually converting into smiles, into mode. Successfully done. And I'm using, let's say I have a molecule, four smiles. So let's have I want to visualize everything in one row. So you can see here, this use the same, you know, uh, commands. So when I use the one single smile, so you can actually, try to convert this into mole and mole to image. But I have a larger smiles or I have a smiles in TXT format as here, CSV format. You can actually use this function and convert into mole and convert into, image format and see and visualize what is inside the SMI files, right? And let's say, imagine I want to write this SD file, uh, write into SD file. So what I can try to do is I can use the same function above that. That's the 4 compounds. So what we're trying to do is we're trying to convert smiles into mole format first and mole into SD file, right? Okay, something messed up. Let me try that. Okay, I have a multiple not much. Okay, not sure what went wrong. Okay, let's try to you know alternate way, right? Okay, okay. So what happened here? So when we are writing one single mole, so this function might be useful, maybe correct. So when we're dealing with a multiple smile, so you need to write a small for loop here. Okay, now we can actually see. I just tested this code, just created a history file already. Let me try to see updated. Sure what is going here. Okay, let's start completely from hash. Okay, so all we are trying to save is moles. We're just trying to create a writer from .chem.st writer, and we're trying to call the for loop to save that, and where compounds test. It just worked. Not sure what's going on. For compound testing. Okay, there might be some space I forget to add. So here what we try to do is we try to create an ST file function object to write all molecules in ST file. And we just writing a for loop to write a molecules in ST file and close the writer object. Now let's see this. So those files has been created. The four compounds test2.stf. So this is what we can find. Right. I know this has been always the learning process. The small mistake, it will take a while to see what went wrong. Right. Okay. So in this today's session about rdkit.chem library. So we completed the first session today. We try to reuse the import the library and try to handle the different file systems and from smiles to mole and mole to st file and mole block, and we try to use the single smiles or multiple smiles at a time and try to play with the molecules, right? So the basic manipulations we have done with today's session, and in tomorrow's session we'll discuss more about handling a bigger file systems like a .cfc file or .st file, and we try to learn more about how to handle by using rdkit, and also the function that we're discussing about handling a different file systems that we completed the basic session today. And tomorrow we're going to discuss about a molecular manipulating and followed by how to calculate a molecular fingerprints and some property calculation by .chem libraries. Thank you, and hope you liked today's session and hope it's informative. And so please comment, and if you have any questions or feedback or suggestions about the article. Thank you. And I'm going to try to upload the video every day and try to capture the most of the features of rdkit and which will be useful for your day-to-day chemi informatica task. Thank you.